All right, so I'll continue the overview of CFN by focusing specifically on our facilities and our capabilities. Emilio has already gone through our in-house scientific program. Now I'll talk about things that involve you specifically. And so our Nanoscience Research Center is divvied up into really 7 facilities that allow you to engage our scientists, our facilities, and our capabilities in a unique and quite intimate way. The first facility is material science and material synthesis and characterization, where you're able to synthesize materials based on things that we already do in-house, via nanoparticles, for example, quantum dots, metallic nanoparticles, as well as nanomaterials, polymers, that are generated and the original idea comes directly from you. So we have that entire suite of capabilities to do that. The second facility I want to talk about is nanofabrication. As you may have noticed downstairs, there's a sign-up sheet to tour the nanofabrication facility during our 1:30 to 3 o'clock time period. This is associated with our clean room, which is in the southernmost part of the Nano Center. This allows you to do a variety of nanoscale lithography, chemical wet as well as dry etching, various processes to deposit metals and other nanomaterials onto surfaces and substrates. The third one, which is related to something that Emilio already talked about, is our electron microscopy facilities that include scanning electron microscopy, transmission electron microscopy, as well as focused ion beam microscopy. We also have the ability to do theory and computation, from molecular modeling to first principle dynamical calculations, variety of techniques that we have in-house. Fifth, we have proximal probe microscopy, where you can do a variety of surface microscopy techniques, including lean, keen, and other techniques. Sixth, we have advanced optics, where you can do a variety of spectroscopies from the near IR through the near infrared down to about 200 nanometers. We can do this through standard tabletop, continuous wave, as well as ultrafast spectroscopy techniques. And then lastly, something that Emilio also mentioned, our end stations at the National Synchrotronic Light Source, as well as, in 2015, the National Synchrotronic Light Source 2. Now, we try to relate all of the facilities that we have to specific types of capabilities, specific types of things that you can do using those types of facilities. And so I'd like to highlight some of those capabilities here that are loosely related to specific facilities that we have, of the 7 that I mentioned. And so with material synthesis and characterization, where we have 3 points of contact, Chuck Black, Oleg Gang, and myself, you can do a variety of things from the synthesis of nanostructures through chemical vapor deposition, through colloidal synthesis, through solid state thermolysis, of a variety of 2,6, 3,5 metallic nanoparticles, as well as rare earth-based nanoparticles. We also have a variety of self-assembly and synthesis techniques for polymers and DNA-based nanostructures. In nanofabrication, the contact person is Chuck Black, and in this area, in the nanofabrication clean room facility, you can do a variety of things from plasma-based etching, dry etching, and chemical wet etching, thin film deposition using sputtering, thermal evaporation, as well as electron beam deposition. You can also do a variety of electrical and thin film device characterization techniques. CV, for example, for electrical characterization, as well as lipsometry and optical spectroscopy. For electron microscopy, the point of contact is Eric Stack, and we have, as Amelia mentioned, also a variety of techniques, including aberration-corrected atomic number contrast, electron microscopy that allows you to go to sub-nanometer resolution, as well as to be able to detect and determine the specific atomic composition of the nanostructures that you're imaging. We have the ability to do tomographic reconstruction, so the ability to take a nanostructure and basically recreate its topology using 3D analysis, as well as energy dispersive X-ray spectroscopy that also helps with compositional assessment of your nanostructures. Fourth, for theory and computation, the point of contact is Mark Hybridson. And we can do, as I mentioned earlier, a variety of molecular modeling, electronic transfer modeling for nanostructures, for individual molecules, and other types of heterostructures. We're also able to do modeling of soft materials, which is one of the unique capabilities we have here at CFN. Proximal probes, the point of contact is Peter Sutter. Here's Peter. And we can do real-time spectroscopic surface microscopy of surfaces. That's extremely important for analyses for catalysis, for nanoscope catalysis. And we can also do confocal optical and photocurrent microscopy concurrently. And that allows us to do variable temperature and high magnetic field assessments also for reaction chemistry-based analysis. 6, with advanced optics, we have 2 points of contact depending upon the nature of the spectroscopy you wish to do, Ola Gang and Chuck Black. Here we can do a variety of single molecule spectroscopies, so actually looking at a single molecular structure and understand spatially as well as spectroscopically the optical properties associated with that molecule. We also can do, as I mentioned, multi-wavelength pump probe types of measurements in CW as well as in ultrafast. And then lastly, with NSLS, with our end stations, again, depending upon the nature of the research you wish to do, Oleg Gang or Peter Sutter will be the points of contact. You can do small angle and wide angle X-ray scattering that allows you to do the assessment of the spatial resolution up to multiple tens of nanometers of nanoparticles in a self-assembly, for example, in small angle. Or at wide angle, we can go to very large 2 theta, so we can discern down to fractions of an angstrom the difference in spatial distribution of atomic crystal atoms. We also have ambient pressure X-ray photoelectron spectroscopy. That's under Peter Sutter's group. And so just to give you an idea of the structure of how these different capabilities are spelled out, here are photographs of each of the group leaders, Eric Stack, Peter Sutter, Chuck Black, Ola Gang, and Mark Harbitson. All of these people, including their group members, will be available for discussions, open discussions, as well as tours of their facilities between the 1:30 to 3 o'clock period this afternoon. So please take note of those areas that you might find of interest and look for those people downstairs. If you're not sure how to get in contact with them in that time period, feel free to contact me and I'll be happy to introduce you. This is the point in time this afternoon that if you have a research idea, if you have something that you're not quite sure about, these are the people and this is the time that you should engage them to explore the possibilities that you might have here at CFN. Other people that are extremely important that you must get to know very well. Grace Webster is our user program administrator. She will become your best friend, as she is my best friend here at CFN. So she's the person who's in charge of facilitating all of the user program activities. And so when you apply to become a user, the first person of contact that you will have, both literally and virtually in the web, is Grace. And of course, I'm here as the assistant director, our leader in safety and operations. Someone, once you come to CFN to become a user, you will become very familiar with, is Bob Sabatini. He helps with all of the safety training with using our facilities and capabilities here at CFN. And so just to give you an overview of the people that are present, just to give you at least some names to try to begin some of these correlations related to your possible research proposals. In Eric Stack's group, we have a number of people that you'll likely be interacting with. Peter Sutter's group, Chuck's Black's group, Ola Gang's group, and Mark Hybertson's group. All of this information will be available to you as either a PDF or need be as a printout. Just feel free to contact myself or Grace to get that information. All of this as well will be located on the CFN website as well as the workshop's website sometime after this afternoon. And then lastly, just to highlight the fact that the capital investment associated with facilities and capabilities is not ending with the 38 million that Amelia mentioned. We have operational from this year to later in 2017, electrophoretic deposition system, 3 brand new end stations, NSLS2 when it goes online in 2015, as well as an alternating current lead. These facilities here were completed in their installation in 2012, and we're expecting to have even more facilities installed over the next several months. All right, so again, this is just an overview for the facilities and capabilities that we have. You'll have a substantially larger period of time this afternoon to engage specifically about different facilities that you might find of interest. Inside of your registration packets, we also have the brochure of CFN. It gives you a little bit more detail of each of the facilities that we have available. I encourage you to read through that and engage that when you talk to our CFN personnel later this afternoon. All right, any questions at this point about any of the facilities or capabilities that we have? Please.
Just, I guess if you could just give a quick protocol of how it would work. We would present an idea or a presentation to you.
Oh, so for today, okay. So the idea that we have in mind is that the first thing that needs to occur for you to become a user is for you to have a sort of a research idea. And so one of the things that we often find as a challenge with our potential users and our current users is matching that research idea with what can be done. And so what we're trying to do, at least in this first part, is to show what things we have. Flash, flash, flash. This afternoon, it's the opportunity to take your research idea, the things that we have available, and to say to one of our staff scientists, is this feasible? Is this possible? Because feasibility, certainly as I'll talk about later this afternoon in my recommendations presentation, feasibility is the #1 issue that we often have with user applications. They have a great idea, they really want to do something, but the facilities that we have available don't exactly match, or perhaps the facilities that exist, period, in the world don't necessarily match with what you want to achieve. And so the discussion period that we'll have this afternoon is really designed for you to confidentially, with any of the staff members here at CFN, confidentially say, hey, here's my research idea. What can I do? Is this possible? Is this even feasible? Based on the facilities and capabilities and expertise that's here. So that's really the goal for that discussion period. And from thereafter, you can say, okay, well, this is feasible. What things do I need to think about to develop the appropriate research proposal? That's really the goal for this afternoon.
Okay. Thank you.
Thank you for the question.